Right. Hello, everybody, and welcome to this webinar organized between Comsof and GE. What we'll talk about today is we'll show you how you can speed up your planning and design of your FTTx project with more accurate cost estimations of your project and your deployment. Also, more accuracy in the designs, and show you how you can also lower the deployment cost through an end-to-end FTTx planning and design process using FiberPlanIT and GE tools. So my name is Jonas Versteft and I'm marketing manager at Comsof, and I'm joined here today with James Wheatley, product line manager at GE.
Afternoon or good morning, everybody.
And with Salvador Peya, solution architect at GE.
Hello, everybody.
All right, so a little bit of details about this webinar. It will take around 45 minutes. There is an opportunity to ask questions. Please do so via the GoToWebinar Q&A window. We will try to treat as many questions as possible at the end. If you have questions throughout the webinar, don't hesitate to ask them. After the webinar, you will be redirected to a short survey with 4 or 5 questions. Please take 1 or 2. It will only take 1 or 2 minutes, so please take the time to answer that. And we'll send out an email with the recording of the session later this week. All right, so a bit the agenda for this webinar today. We'll start off with a short introduction about FiberPlanIT and Comsof, and also introduce GE. And then we'll talk to you about the integrated FTTx project workflow that we want to present today using FiberPlanIT and GE products. And as I said, at the end, there's time for questions and answers. Okay, so let me introduce you Comsof. So Comsof is the company that created the product FiberPlanIT. We are based in Ghent and have an office in Toronto in Canada. And since 2008, we have worked on FiberPlanIT, which is an FTTx network planning and design solution. It is sold as a software, but we also offer planning and design services. We've done over 200 projects in more than 40 countries since the start of FiberPlanIT.
Yeah, and just a few words about GE. So we provide a physical inventory solution. We've been in the market for nearly 20 years now, and we have over 160 customers worldwide, including a large number of the large tier 1 operators. Our solution set supports the entire plan, design, build, operate and maintain network lifecycle, and we see the inventory there at the center of those processes, and looking at how inventory can support those processes and maintain the data that's fundamental to support the other operational processes.
Right, thank you. So what we'll talk a bit about today is the different stages within an FTTx project, and how both of our solutions can assist you in your project workflow and how they work together. So the first stage I want to talk about is the planning stage. So this is the strategic planning stage. So you have to come up with a business case for your FTTx project, decide where you want to roll out. Also, you need to know how much it will cost to roll out your network. So really that whole business case building of an FTTx network. And for this, we have an integrated solution where we use the simulator, FiberPlanIT simulator, together with GE's GeoSpatial Analysis. And later in the presentation, we'll show you how these two can work together. Then the second stage, the design stage. So once you have decided where you want to roll out your network, which type of network you want to roll out. So you have selected a city or a rural area, for example. Then you go into the design stage and need to come up with a high level and low level design. So you need to know exactly where to place your cabinets, how to route your cables, which type of cables you need. And for this, we have an automated design solution called the Designer. And the Designer can work together with Mobile Enterprise, GE's mobile solution for field surveys, also for collecting your GIS data, which is needed for the design stage, and also for field survey to make corrections in the field, watching the real life situation. Now, Designer is integrated within Smallworld PNI, GE's inventory solution, to have an integrated design, build, and operate workflow where you can take the design, which is done with the FiberPlanIT Designer, and take it further throughout the build out of the network and the operational stage. Now, let me first explain you a bit more how planning and design automation works with FiberPlanIT. So this applies to both our simulator solution and our designer solution. Now, basically it is taken in GIS data, detailed information, geographical information of your area, like buildings, streets, existing infrastructure like poles or ducts or manholes are all taken into account. And this is combined with a set of rules, meaning the type of architecture that you want to deploy, like, for example, a PON or point-to-point network, but also with detailed cost information, unit cost information of material and civil works. So all this information is taken into account to do a design. So it calculates a detailed design, determining all of the routes, all of the locations of equipment. And it also writes out a detailed bill of material, giving you the insights in the costs that you need for your project. Now, this workflow is supported for many different types of FTTx deployment. So it's not only for fiber to the home, so fiber to the building or fiber to the curb, reusing existing copper infrastructure is supported. It can also be used for fiber to the antenna planning or 5G front haul, backhaul fiber planning, and also for network design, upgrading existing HFC networks, doing node plus zero type deployments are all supported with our solutions. Now, like I said, the first stage is the planning stage, strategic planning stage, and for this we use both simulator and geospatial analysis. So simulator is really focusing on providing detailed cost estimation. So it's a completely automated solution that determines the costs based on a real plan, a real design that is being done on the GIS data. And this cost information can then be shared to the geospatial analysis tool that where you can combine both the cost information with other types of marketing information that can help you to make the decision on where to roll out and to see whether a business case is viable. Now, to give you a glimpse of the simulator, so this is our simulator interface where it is showing you the different types of input data that are required. So it shows you on the left-hand side the rules and material. How you can specify the rules and material. So there you specify all of the architectural requirements for your network. So how many fibers each home requires, which type of cable deployment you want to do. Also, particular constraints to the network design. For example, how many homes you want to serve from a cabinet. And also detailed cost information is required, because that cost information is used to determine most cost-effective routes during the planning and the design. Within the simulator, it's possible to specify different types of rules so that you can really fine-tune the type of architecture that you want to use. It's also possible to load in different areas. So in the second section, you can specify the GIS data that you want to use. So the type of area that you want to design, and it is possible to specify different areas if you're trying to compare the cost of different target areas within your region. This is possible to then load in these different types of GIS data, and then you can choose to simulate whichever type of rule, whichever type of area that you want to do. And here you can see a outcome of such a simulation, showing you an area of 35,000 homes passed with an underground deployment, which is calculated in around 2 hours, showing you the cost information, high level cost information, giving an indication of the deployment cost and activation cost. But then also detailed costs are calculated for every simulation that you do, showing you exactly for each layer of the network what the cost would be, divided in a home's passed cost, so only cost that they needed to pass the home, then a home activated cost, and detailed information for each type of civil works or equipment that needs to be placed to realize your design. So very detailed information that can give you the confidence that you have accurate cost results, so that you can trust your business case. And now let me hand over controls to Salvador to explain the geospatial analysis solution.
It's better when I'm not muted. So as I was saying, what we're gonna see now is the results that we got from this simulation. We got the bill of materials, as Jonas was saying. We got the right architecture, but what we want to do now is to see them and enhance them with additional information. So we're gonna put them on the map using geospatial analysis. And then we can integrate these different data sources. So information that we have profiling or just getting information about the areas where we want to deploy our network to make and create the best business case that we can create. That is just where we want to deploy the fiber, how much it's going to cost, and then getting all the different reports and so that we can actually make the most informed decision. Here is an example of, for example, the information that we can see. So this is our tool GeoSpatial Analysis, and what I've placed in here is all the distribution cabinets that we got from a simulation, and then we've mapped them against the income, district income in this area of the city in Belgium, in Ghent. So the darker the blue, the higher average income there is in this region. We could have done it against other type of public indicators. So this is really a way to make sure that we have to understand where we are planning and thinking about deploying our network. But we don't stay just at this level, so we can go a bit further in this analysis route. So for example, we have these different cabinets, and then once we have to start deploying them, so just building them on the field, we need to make a decision where we're going to start. So which criteria are we following? Are we following alphabetical order? Are we following the number of houses that is covered by each of the cabinets? Or, for example, as we can see in here, are we starting based on the cost? So we're gonna get the ones that are cheaper to deploy. Let's say, let's do it at the beginning, and then the rest, the ones that are more expensive towards the end. So we can see this information here. So what I'm showing is that on the green dots are the most cost efficient, so the cheapest ones, and then the red ones are the more expensive. And this is a very good approach. But for example, And if we keep just working on this, crunching a bit more the data that comes directly out of the simulator, we can get these results. And what we see in here is in white squares the cabinets with a quickest return of investment, and then in the green dots they are the cheapest one. So it really, we try to get all the information to you guys to make the decision saying, oh yeah, which are the best cabinets, or we're gonna start deploying in this case for this area in the south, where it just, we have the cabinets with the quickest return of investment. It's the area with, we can see, with a higher average income, which means we really want to make sure that these customers are ours and the competition doesn't get there before us. So this is what we can do when we get the results from the simulator. And now we're going to move to the next stage. So our starting point here is that, well, we see the process. This is the whole workflow with the end-to-end. So since once we have the decision that we're gonna deploy the network until the network is built and documented in the system. As we were saying, what we're gonna use is the same interface when we're using when we're on the desktop. So we're gonna be using Smallworld PNI application, and then we have the FiberPlanIT Designer plugin. So we are able to do all the tasks that you want to do with FiberPlanIT inside Smallworld using Smallworld tools and integrated with the data that we already have in Smallworld. And I'm going to show you that in a minute. Then we have this second stage. So this is what we start on the initial design. Then we go into the second stage. So the field survey, we're going to use Mobile Enterprise for this. And I've got a video to show it. And this could be a good example. As Jonas said at the beginning, we could use it to collect GIS data, or we can use it to modify and do some corrections on the first design done by FiberPlanIT designer. Then finally, once we're happy with it, it comes back to Smallworld, comes back to the back office. We can do the final changes, and then automatically import all this data into normal Smallworld objects, so that we can act and treat this project as we would be any other design build project that we have in Smallworld. So we can use our report pack, we can use the workflow, and all the different tools that we have just available for when we're designing networks. So what we're gonna see in here, let me start the video. So this is what I'm showing here is Smallworld 5. So we are in an area in the south of Exeter. As you can see, it for all of you who are familiar with Smallworld, just it looks like a normal Smallworld application. The main difference is that we have this bar in here just above the map. That is the same bar that is the FiberPlanIT plugin. So I'm going to be using it in order to interact with the designer and in order to create the network. So what we're doing, and in this case, we're not getting data from any external system. So we're taking advantage of the GIS data that we already have in the system, and we're gonna just feed it inside the plugin of FiberPlanIT Designer. So what we're doing here is we've just loaded the addresses that we had in the system, and now what we're gonna do is I'm gonna show you how some objects that we already have in the map. So in this case, I'm going into the right-hand side. So we have a hub. It's a normal PNI object, and we're gonna see how the plugin automatically picks it up, and we can select if we want to include it in our calculation or not as our central office. So we have this interaction between real objects that we have in Smallworld in PNI, and then what we're using to calculate when we're doing a design. In this case, we're thinking about reusing. We're proposing to reuse some infrastructure, and as we can see, we have the list, and from the list we can actually get into the details. So if we're not sure if we want to include that manhole or not, we are able to navigate to the object from the data that we're using on the plugin. As I understand, and probably you already know, that how it works. Just we've done a couple of examples. You can see that we can reuse the small world data and load it as part of the input data for the calculation. For the rest of the objects, what I'm gonna do is I'm gonna use this export all feature, because we believe, or I believe, that it's not where the most interesting part of the presentation is, of the video, is how I'm exporting objects. So now we have all the information there, and it's the moment that what we're gonna do is follow the standard FiberPlanet designer workflow. So we need to create the additional possible trenches. We need to get the crossings, and one of the things, and this is what I'm doing now at the moment, or we're doing in the video, is we're using small world tools to correct the data. So when we want to correct, for example, this street center line, so that, as we can see, it's not very straight. So what we're doing is using the trail functionality. So all this good and all these capabilities, all these functions that we are used to use, because we use them every day when we're planning networks, as we can use them as well when we're planning, in this case, our using this automated way to deploy FTTx network. So now that we've done this, we can calculate we're gonna create the possible trenches. As you can see, we have the trenches, and now they're following the line that we wanted. And the next step is I think it's a little correction in here in one of the crossings. So again, we're gonna select the object, and we're gonna see an editor very similar to a small world editor. We're gonna untick the box, and then this one is one of my favorite parts, is a small jump in time. So we have fast forward all the calculation of the drop layers and the area, and processing the area. So we have it ready. And finally, what we have to do is, similarly as Jonah said, we're going to apply our rules. In this case, we're creating set. Can be different types of rule set. In my case, I'm going to change the size of the distribution cabinets. Again, these rules can be modified or not, can be loaded in advance, and we can compare and run these different exercises based on different rule sets. So now we've run the calculation while I was talking. So it has run the simulation. We can see that it has reused our existing hub as the central office. Then we have these different distribution clusters all around Exeter. And what we're gonna do now is saying, okay, this is a very good example of what we can do. It's the first round, but we're very good planners, and we have some knowledge that we are somehow not able to fit in the system, because the system is always calculating the most optimized network, and we know that because we have some characteristics of that area, that this area that I'm pointing at now, so this little mu, it needs to be a cluster itself. So what we're doing is we're manually editing this data. So in this case, we're manually creating a distribution cluster in here. We can see the size, but in this case, what we need to do is to lock it. So when we run the calculation again, we calculate the network another time, and then we're gonna see that this, as we can see, this little cluster has been maintained. So we are able, what FiberPlanIT Designer is giving us is the first approach. Then we can modify it either on the desktop or on the field, and I'm going to show the field in a moment. And then finally, we're going to be able to import it into PNI objects, because at this time we're still on normal FiberPlanIT objects. You've seen a quick glimpse that we can get also from here direct access to the bill of materials. And then we can also have the different simulation that we've done. So different manual modifications and creation of different clusters can be recorded, so that the planners can decide which is the best approach. And finally, when we are just saying, okay, this is the network that we really want to build, so what we're going to use is we're going to launch the wizard, which is this icon that it's highlighted in here. We have a menu, an import wizard, where we're going to be able to do the matching between the FiberPlanIT objects and the and Smallworld PNI objects. In this case, I think it took me roughly around 1 hour. And what we have is something that is much familiar to, or hopefully is familiar to all of you. It's normal PNI object. So without any manual intervention, suddenly what it has done, it has placed the different elements. In this case, an access point. You can see that the account code, so it automatically comes from the plugin, and it managed to do all the connectivity. So we've seen it places the trench, it places the splice and the terminal. So we ended up, after running the whole process, we ended up with the network planned in a design in Smallworld PNI. This is what we did the back office. As I said, there is still another part that we need to complete. So we mentioned that we can do the field survey with Mobile Enterprise. So Mobile Enterprise is GE's mobile solution. It can be used to visualize the assets and also modify the information both in redlining and bloodlining and send it back to the back office, to Smallworld. In this case, we're also able to work with FiberPlanIT and edit some of the data and the design that we have. So that's what we're going to do. So as you can see, we can see different demand points. And now what we're going to do is we have a first simulation. We're going to go into the field, modify the route of the feeder, and then connecting this church that we see on the map to the network so that we can actually give them access to FTTH. So what we're seeing in here are the different clusters. In this simulation, they are smaller than what I showed before on the desktop version. And what we're going to see, we're going to select some of the objects, and then we're going to move this feeder route that is in Oakhampton Road, and we're going to make it go on the other side of the road. So we are able to move the proposed locations because we're on the field, and we see that, for example, in this, even if it's closer to a road crossing, there is more space, and it's going to be easier for us to do it. And again, we're making the network less optimal, but maybe easier to build and maintain. And this is where the different planners, they can bring their knowledge. So, and here, what we're doing is just simply drag and drop. So we can see the route that is highlighted in yellow. We're drag and drop, and then it automatically snaps where we want to snap, which is where we have the other possible trench. Once we have done this, what we're doing in here, it was creating this additional demand point. We should complete and get some more information if we want it. In this case, it's just only one house. And we're going to create as well the possible route, so connecting from the network to the object. And then we can send this to the back office. Probably in the back office, what we would do would place the drop box to make sure that we can make the connection, and that's it. So with these two short videos, what we've shown is that we are able to use Smallworld PNI to get the information, run through all the different steps on this FTTH optimization and automated design, modify it on the field or on the back office if we wanted, and then finally import it into Smallworld to get the documented network and get the reports as we usually do.
Okay, thanks, Salvador. So what we saw there from Jonas and Salvador is the first two steps really in the plan, design, build, operate and maintain lifecycle. So that's how we can effectively design a least cost network. Of course, the design is only the first part. We then need to build that network, we need to operate it, and we need to maintain it. And the Smallworld product set provides a range of tools that help in the ongoing support of those business processes. So, for example, we can provide capabilities that streamline the network construction process. So being able to identify all the different tasks that are required within the network construction process and manage the allocation of those tasks. we can look at how we can streamline and accelerate the as-built update process. So using the same set of capabilities that Salvador just showed us there, once the network has actually been physically constructed in the field, the construction crews can use the mobile enterprise solution to modify the data to reflect the real as-built state of the network, and that can be pushed back and automatically update the inventory information held in the back office. So we've got a much quicker round trip of the information, so we can start offering services on that information much quicker, and gone are the days of having a big stack of paper as built on the planner's desk that he never quite gets round to updating, because many of the processes that come downstream rely on having good quality data in the inventory, especially if we look to automate some of those processes as well. I'm sure many of you are working with a wide range of contractors within your construction and maintenance processes, and being able to integrate those contractors into the overall processes and workflows can provide a number of advantages in terms of cost savings and time savings. So the GE solutions are able to integrate the contractors into that network construction process and treat them as part of the overall organization, and that's benefits to both the contractor and to you as the operator. So once we've kind of some of the benefits around network construction, network build, and then as we look to operate and maintain the network, and there's a number of different areas that having up-to-date and accurate inventory data is important around. One particularly is around being able to automate the provisioning of services. So looking particularly at this from a physical network perspective. So you get a request for service from a customer, can you actually fulfill that service? So while you may be able to automate that at many layers above in the logical space, you really need to be able to have some intelligence and some automation in the physical space as well. So we've seen our solutions help operators avoid having to roll trucks to determine whether they can supply service and all those sorts of things, with the cost savings that results in. And then finally, of course, while we're maintaining the network, we'd all like to hope that it would all operate without any faults, but that's not quite how things always go. So it's very important to be able to reduce that network downtime by resolving those faults very quickly. And location is a key element of that. And so with our spatially based inventory solution, we're able to provide support to be able to help either guys in the NOC, guys in the field, or other systems to be able to locate those faults very quickly. So that's a range of different ways to improve the capabilities there. And so just to give you a couple of customer examples, so these are both customers that are using the integrated solution between the FiberPlanIT and Smallworld. So there's two examples here. One is Cordia in Australia. And now Cordia are the main contractor, or one of the main contractors, I should say, for the NBN's deployment across Australia, which I'm sure if you follow the telecoms press, you'll be familiar with that. And as I say, they use the Smallworld and FiberPlanIT to support their design process and supply information to Cordia to support to NBN to support that overall process. And they needed to look to optimize that process to be able to drive savings and realize some revenue from the contract that they had with NBN. So they've been able to reduce the design process from 78 days to 51 days using the automation that's provided within the solution. And that's focused in a couple of key areas. They hope to be able to further optimize that by looking at other areas, such as the field solutions that we were exploring there, to be able to drive further savings in that design process. And the other example is Telkom in South Africa. They're deploying an extensive FTTx network across South Africa. They've used Smallworld for many, many years now as their primary physical inventory solution. And now they're working with their prime network design and build contractor for the FTTx network to be able to use FiberPlanIT and then to be able to use that to do the network design and push that design automatically into Smallworld, so that once that's complete, they have the record of that in the inventory. And so that's, you know, being able to again streamline the process, be able to result in a least cost optimized network design, and importantly, getting that information in the inventory to support the ongoing business processes. So I'll hand back to Jonas.
All right. Thank you, Salvador. Thank you, James, for that explanation. Yeah, so we've reached the end of our webinar today. As a conclusion, I just want to highlight the potential, the value that you can get from the integrated FiberPlanIT and GE solutions. So as James indicated in the case for Cordia, because of the automation and the integration between FiberPlanIT and GE, there's a significant time saving in your planning and design process. So it really, the automation of the FiberPlan solution, applying the design rules automatically on every single area that you do, creating all of the network elements automatically within the PNI solution, providing that connectivity and that detailed design view and detailed information on how to build the network. That's a huge time saver, which if you want to do this manually, it's very repetitive work, and the chance of having errors is also a lot higher. Now, the second part is really because of the optimization algorithms within the FiberPlanIT solution to do cost optimized routing. It allows you to save 5 to 10% in trenching and cabling. So that's what we have seen in many of our customers. So real construction savings that can be achieved. So yeah, the FiberPlanIT solution really, has integrated advanced routing and clustering algorithms, trying to minimize the cost of equipment and work. So that's why that unit cost information, which is loaded together with the rules and material, are so important. So as you might know, for an FTTH project or FTTx project, might be that you have existing infrastructure, you have options to go aerial, you have options to go underground. There are many types of doing underground deployment. So loading in that unit cost information about the different routes that can be followed, all of that information is really being used within the solution to determine how to design the network. And yeah, so what we wanted to show today is show you how you can get this value from that integration of the different products of our two companies. Now, as final part of this webinar, we can answer some questions that we have received. So if you still have some questions, please don't hesitate to ask them via the GoToWebinar Q&A window, which should be located on the right-hand side of your screen, and we'll try to answer most of them. One of the questions that I get here is one for GE. The question is, can we plan the network inside the building, multiple floors? And they specifically ask about using a PNI building. So probably that's information that's stored within PNI. James or Salvador?
Yeah. So the FiberPlanIT solution will include the costings of what it costs to deploy into the building. So it will create the lengths of cable that's required and any infrastructure that's required, the splices, terminals, etc. At the moment, it won't automatically generate that within PNI, and the main reason is there's no technical reason why it can't. It's just the complexity of providing the data in a realistic way. So if people have the information about the inside of the building and stuff, that's often the barrier, is that data doesn't exist or is incorrect. We have done various prototypes that show you can automate that. So my contact details are there. So whoever asked the question, feel free to drop me a note. I'd be more than happy to discuss that in a bit more detail.
Right, thanks, James. Yeah, and related to the FiberPlanIT part for in-building design, so it is something that we are looking into to get more detailed cost estimate in an automatic way for the in-building design, as it also has an impact on your outside plant. But yeah, it's a matter of having all the data available and collecting that data in the field. Another question is it possible to integrate surfaces for calculating the to-build costs, like tarmac, gravel, etc.? So for FiberPlanIT, it is possible to integrate those surfaces. So for the underground deployment, it's possible to indicate different subtypes for your trenching, and for each type of surface or each type of underground trenching, you can specify a subtype and associate a cost with it. So the software will then use that information to optimize the routing of the network, but it will also reflect in the bill of material. Yeah, I think that answers the question, unless James or Salvador, you want to add anything there.
Only that, in a couple of the projects that we've been working on together, we've been automatically generating that information to feed into FiberPlanIT from the underlying cadastral data as well. So taking that detailed information from the national mapping agencies and being able to set those subtype values automatically. So it's a fully automated process.
All right, thank you. Okay, one of the questions here. Will it be a single user interface, GE and Comsof, if I opt for a combined solution? So as Salvador showed in the demonstration, so the designer is fully integrated within the Smallworld PNI system. So you use Smallworld PNI as the front end for your design. So the only thing is that the defining the rules is within the FiberPlanIT user interface, but yeah, that's a seamless process. So you stay within the Smallworld PNI environment. For simulator and GeoSpatial Analysis, so these are two different user interfaces, but they are integrated, so you can for the simulation results coming from simulator, you can easily go to open your design results or your planning results within the GeoSpatial Analysis solution. And I think mobile enterprise, I don't know, Salvador or James, if you want to provide some information there. It's
fairly seamless. The integration between the Smallworld desktop solutions and mobile enterprise is quite a seamless process. So for the end users, they're able to switch between the two quite easily. So you're just modifying some of the data and then pushing that back to pick that up and use it on the back in the office.
All right, thank you. Just looking here. Okay, one question here, maybe a final one as we're reaching the end. Where does the data come from for the simulator? Is it an export from PNI, GSA? Can you combine with data from other sources as well? I don't know, James or Salvador, if you want to.
Yeah, sure. So GSA is able to take a wide range of spatial and non-spatial data and combine that together and then it can then feed that into simulator. So if you've got information from national mapping agencies or network data held in other systems, whether that's GIS or CAD based or whatever, then GSA can get hold of that. It could be multiple different systems. So we've seen examples where customers have got different systems that they've acquired through acquisition covering different geographic areas. That's fine. GSA can talk to those. It doesn't, you don't physically migrate the data. GSA just accesses that data in the location where it resides in the source system, and then it can create the appropriate model that's used by the simulator and push that data into the simulator. So that's very straightforward. And similarly for designer, you need to get the data within the Smallworld environment. And typically that will come from background mapping sources, Ordnance Survey in the UK, for example, and other cadastral providers in your local country. And then that's a case of configuring what information you want to push through into designer. That'll obviously is configured by default with a set of parameters supporting the existing Smallworld model. If you've got modifications to that or specific background data requirements, they can all be configured in to feed that data through.
All right, thank you, James. So we've reached the end of the webinar today. I want to thank you all for attending. I want to thank James and Salvador for the excellent presentation. If you do have some questions, and there were some other questions, we'll answer them via email. If you do have some additional questions, you can find the contact details on this slide, so please don't hesitate to reach out to us, and you can expect the recording of this session later this week. Thank you.
Thanks very much.